So like here is my laptop and here is my big screen, which I will like be presenting from, which you are seeing now. So like if I am not looking to you, like it's just like because I'm looking to the presentation. Uh, I believe like most of you may have like the same. So it's just like because like it's bigger. So let's start. Today we are gonna talk about introduction to ROS, Robotics Operating System. So before diving into ROS, so imagine that you are a software engineer in a software company and you can code in Python or in C++. And your company have like a new project. But this project, it's not only a software project, it's also like a robotics project. So like it could be like a robot arm, or it could be like a vehicle that have some sensors, and you need like to develop some like sort of module for it, like to do a specific task. For example, like imagine that you have a vehicle that have a lidar or have a radar, and you need like to detect the speed of the surrounding vehicles around you. So this lie under the robotics category. So like, and if you will work with the robotics, probably you will need in one point or another to deal with ROS, Robotics Operating System. And we will talk like in more depth why we'll need like to use ROS and what is ROS. So this is our table of content. It's like looks that it's very big, but don't worry, like we'll try to make everything like as far as simple as we can. So we'll go through like an introduction. I will show you like some projects that have been done with ROS. We'll talk more about what is ROS. We'll talk why we use ROS. We'll talk about like the main structure of ROS, or the most important part in ROS, which is the node, and then what is service, and then there is a package that is called transform or TF package. It's also very important in robotics in general and in ROS. And then we will see like simulators that we can use with ROS, and then the visualizer that we can see like the sensors messages or messages that we define on. And then we will like just wrap everything up, and we'll go for questions. So let's start. I have prepared for you like maybe 3 videos to show you like what we are generally doing with ROS. So let's start with the first video. Can you see my screen? Can you see this video? Okay, great. So I believe like maybe some of you have seen before, like for example, like this robot cleaners that move around the house and clean it. So this robot cleaner can have like a camera, as you can see, and it can have a lidar, and it navigates through the house to like clean, and like it have like some brain and then on this brain we install like some sort of algorithms that can deal with this data and this stuff. So this is like kind of a robot that's doing the same function. As you can see, like here we can see like the camera, what this camera can show us, and here is the robot, and this is like this points, this is colored point is a point cloud. And as you can see, like here there is maybe some sort of a white trace which called like an occupancy grid. So what we are doing here is that we are taking the data from the camera, and we are taking the data from the lidar, and we do some algorithms to know the position of our robot in like the real world. And then we are trying to see what is the free cells, or where is the drivable areas that we can move, and where is the obstacles. And as you can see, like it only allowed to move in on the white cells only. So this is a typical application for ROS. And what we are seeing now is a tools that ROS provide, and we'll talk in more depth about like these tools. So what you are seeing here, this is called RVIS, and this may be RQT, which is like a ROS visualizing tools, and we'll talk in more details about this. So let's see another video. So as you can see here, also like a bigger robot, it's like a vehicle that is moving, and it have like a robot arm above it. It have a lidar. This is like so let's talk about more about the sensors. So this is the lidar. As you can see, like this is how the lidar is looks like. This is called like a real sense camera. The real sense camera is like kind of a 3 or a depth camera. It's called a depth camera. It's have like some kind of a point cloud with an image, and so like it have like its own sensors, and they are trying to do like some specific task, as you can see. So they need like this robot to do a specific task, maybe pick something from a place and put it in another place. And as you can see, they are using ROS in order to achieve this. Uh, so like why they use ROS, we'll talk about this later. So as you can see, like ROS can help them like in navigation, in visualization of where is the ROS in the environment. It can also like help them like detecting the obstacles around them. So like it just like translate, we can say it translates the information from the sensors itself to a visualization that we can see and debug through it. And then like it can like also make another custom messages that we can talk about later. But like this is the main idea of ROS. So as you can see here, like here is like the robot in the real world, and here is the robot in our like visualization frame, and it's trying to see where is the robot in like in our world or in our room. So as you can see, like the robot have picked some object, and it needs to put it like in a specific location. It needs to make a map for the surrounding in order to localize itself in this environment. As you can see, like it's just like giving the robot like some challenges, and like the robot can detect where it is by like the camera and the lidar and stuff like this. Okay, so let's go for the last video. So also like here is also a drone. The drone can like be it lies under the category of robotics as well. So like robotics, it's not only like ground vehicles, it's also can be like vehicles that can fly or underwater vehicles. So like anything that's have a sensors and maybe like navigate like through itself. So like this is robotics. This is lie under the robotics category. So as you can see here, like the drone, like as a drone like going up, we can see that it's have a lidar that maps the surrounding. And also if you could see this line, yeah, if you could see this line that is being drawn, this yellow line, this line is the path that the drone is taking. Also, this we can visualize on the RVS. So like why we are visualizing, so whenever something not good happened, so we can like debug, and also like it helps us like maybe to save the data for later use, and we'll talk more about this. So we have see an introduction to ROS. So what is ROS? Let's talk in more detail. So just bear with me in what is ROS and why is ROS. These two parts will have like a lot of like writing. Just bear with me, and we'll later will like talk about everything in more details, and we'll explain everything. So just bear with me like for what is ROS and why is ROS. So what is ROS? ROS, it stands for Robotics Operating System. So like like that it's kind of true. Like operating system is like Windows or like Linux, which we are users, we use. But under the hood, there is a lot of operations that is being done, which we don't know anything about. Like how like the process executes, which one to like should be first and which one second, and all of this stuff is like held by the operating system. So like that's what it's called about by operating system. So like we know Windows, we know like Linux, and we know like Mac OS. So like all of this is operating system. And for mobile phones, there's Android, there's iOS. All of these are operating systems. So ROS is like technically it's working on a Linux or a Mac or a Windows. So ROS is working on the top of this. So but it's kind of doing some underhood stuff that we call it like robot operating system. So it's work above a system or an operating system like Linux or Windows, but we call it like a robot operating system because like it's do some stuff under the hood, which we are not somehow responsible for. So like it's make our life easier in somehow, and we'll like talk about this. So the ROS as we can see can like, so you have like some modules. You wrote a Python code or a C++ code. So what they can do is they can communicate. So like for a robot system, your code can like reach millions lines of code. So like you need like to make this as a modules, like a small modules, as any complicated software system. And you need like an efficient communication between these modules. So the ROS is provide this communication API, so we can send a message between these nodes through topics, or we can send a service, and we'll like talk about all of this. You can use like a C++, a Python, or anything like with ROS. It's also a free and open source, and you can like use it like for your industrial project. It's okay. So ROS have like a nodes, a message, and a topics. So what is node and what is the message and what is the topic? As we said like before, the node is a program that we have is doing like it can be C++ or Python. So why we don't call it a program or executable? Why we call it a ROS node? So the difference that it have like kind of a definition of if it will send a message or it will receive a message, a ROS message. So like that's why we call it a node. And the ROS node can send a message or can receive a message, a specific type message. So like the ROS is providing a built-in messages. So for example, like for the LiDAR, it have a specific message for the LiDAR. For the camera, it have like a specific message for the camera. And you need like to parse in this message in the correct way. Otherwise, everything or you can't visualize your message, or you can't like do anything with this message. So like you need like to follow the rules of like how the message structure is looking like. And ROS topic. What is ROS topic? So the ROS topic is like the road or the bus that is sending the message through, or the network that is like sending the message through. So let's imagine a factory, and this factory take a raw material. This raw material is like the raw sensor data. This factory is doing some process, and this process like is like doing like an algorithm or some stuff like for the robot. And this factory is having a final product. So what is this final product? This final product is a message. So like imagine like a factory take a raw material and it's produce a phone. And then the delivery company come, take this phone and ship it to the customer. So like the shipment route is the ROS topic. And the product itself is the message. We can like define it as a message. And the ROS node is the factory, the process that is done in the factory. So like you can imagine it in this way. So what is ROS service? So we talked about ROS topic, but what is ROS service? So usually like we'll talk about also about this like in more details later, but like what is the difference between ROS service and ROS topics? So like the topics is a communication way between nodes, but it sends messages all the time. So like it doesn't stop, it just keep sending whenever like some action happen or something trigger. For example, like it can be sending like every 1 second or every 0.1 second. You can define whatever you want, like depend on your application, or it can sending a message every time like a function is triggered, every time it's received a message from another like node, for example. So what is the difference between the topic and the service? So the service is only sending and receiving message when a node requested. So like a node, there is like some action happen that it's trigger this request, and it go to another node and ask it for that I have a request. Can you do this service for me? And then the other node do the service, which can be anything, any kind of algorithm, and then it have like a feedback or a response. So like this is the difference between the service and the node. So why ROS? So like just bear with me and we'll talk about all the details like in more all the details later. So why ROS? As we said before, like ROS is an open source robotics software. It's free for private and commercial use. It has many built-in software packages. So like you can use like a lot of packages that is built in from the ROS itself or other guys or other people that have developed. Its communication infrastructure is like it will be sufficient for you. It's very good. It's very fast. You can like run a Python code and C++ code, and they can communicate without a problem. They have like a built-in messages that you can use, and these messages you can also visualize on RVS. You don't need like to use like any other visualize like Matplot or anything. It will be harder for you like to work with like, for example, a point cloud through Matplot, because like Matplot will only show you like the point cloud from one angle, and you can't like dynamically control it. But for RVS, you can like dynamically control it however you want. Also, the message passing, it facilitates the communication required between process, even if they are on different machines. So like you have like different machines, and you can send the service from my machine to other machine to trigger some process like on a JSON on any other machine. There is also like something called ROS bag. The ROS bag is a very good tool that can help you like saving the data that you take from the sensor. So for example, I have like we have like our self-driving car. We need to take around like a tour around the city, and this self-driving car like now we are in summer, but 2 months later we will be in winter, and we can't move anymore like in this snow. So we go with the self-driving car in summer. We take a data, and I use ROS bags to record this data. So while we are moving, while we are receiving a data from the sensors, we are saving everything. Like we are saving all the data that come from the sensors. We are saving all the data in the specific time that they came, and when we replay the data, everything will come in the same way that we were taking the data. So it's a very efficient, so it can help you like develop while you cannot like take a new data, or you cannot like work with your data right now, you cannot go. So it's save you a lot of time, save you a lot of resources, because like every time you will go with your vehicle, you will need like maybe a benzene and you or electricity. So all of this is resources. So it can make you like develop like without like using a lot of resources. So like this for the message passing, let's continue. So the community support. So like the ROS have like a huge community, whatever you are doing or whatever you are developing, and you stuck in some part, you can go on a robotics community or ROS community, and you can ask whatever you have like, and probably you will find an answer, or even like before you ask, you can check like previous frequently asked questions or anything, probably you will find your answers to this. So like it's a really big community which you can also use. So also ROS is using like ROS, you can use with ROS like many other software technologies, like Gazebo, for example, is a simulator, which will like show later. And OpenCV, I believe like most of you like know, if you dealt with Python or even C++, and you know like this object detections, or like you are like having like uh, camera give you an image. So like probably in one time or another you will use OpenCV to make some process on your image. MoveIt is a very important library. So MoveIt like can help you like in moving your robot, navigate through your environment and moving your robot. So like it like save you like the hassle of developing everything from scratch. If you read the documentations, you can use it with your system. It have like a lot of algorithms and a lot of motion planning algorithms that you can use immediately. So the last part for wise ROS is the visualization. For me, this is one of the most important parts. So as we said before, ROS have a built-in plugins that help to visualize the message directly on RViz. So what is RViz? RViz is the visualization tool that ROS provide. What is a built-in plugins? So let's say that you have a node and you are using a built-in message that this node or a ROS is defining use, like for example, for a point cloud. This point cloud, it have a data. It have like the time that this point cloud was taken. It have some fields only, like time, the data, each point where it is, and all of this stuff. However, what will understand that how this data should be shown? So there should be a plugin that transforms this data to a visualization. So ROS usually for each message it provide, or each built-in message, it provide a plugin for it. So let's imagine that you designed a custom message, and this is can be done. So I can design a custom message for my application. I need like some custom message that, for example, like the ROS message for example, for planning. It have like some stuff about the locations, but I need also the speed. So I can define another message that have the location and speed. So, but how I can visualize this custom message? I need to write a plugin for it. I need to write a plugin that will like makes the RViz understand how to visualize this message. That's like the idea behind the plugins. But most of the built-in messages, which probably will be enough. It have like a plugins. So here is like a quick overview. Like ROS, we can use it with C++, Python, we can use it over a Linux or over a Windows. Usually, like most of the people that use ROS, they are using Linux. However, like a lot of people, like the ROS have developed in recent years, and now like it's work good on Windows. So like I believe like some people can use it with Windows. And also, if you know about NVIDIA and parallel programming, also it can be used with ROS. So ROS is like a flexible operating system. You can use any programming language. You can even like use parallel programming through it, and you can do a lot of stuff. So let's talk about the node. What is the node? So can you see, or this is okay? So imagine like we have like this is a node and this is another node. It's just like we can say it's not a node. We can say like it's only a program, executable. Some program that you write that is doing some function. It can be written in C++ or it can be written in Python. So what make it a node? So like a node is that you have some built-in libraries from the ROS that it makes this executable can use the ROS messages, the ROS visualizers, the ROS everything for the ROS. And for example, like this executable is doing a thing and this executable is doing another thing. They can communicate with the ROS topics. So that's why we are calling them nodes. So the node is the main part for the ROS, or where like the ROS is like it's just some modules that communicate together. So here is like a typical let me just open it in just a moment. It's just because like this is a GIF, I'm opening it from a PDF, so it will not be shown. So like I will open it from the slides itself. So as you can see, here is a node that is doing some specific task. And after it does this specific task, it wrap it into a message and then it send it. And another node can subscribe to this message. So that's how like they can communicate. So like for example, I have an image, for example, and I have this image is being input to this node, and first I need to crop this image. So this node is just cropping this image, and then it publishes the message of this cropped image through the topic. And then another node takes this cropped image and do some filter on it or anything. So like that's what the nodes are doing. So for a service. So what is service? So the service is also a code, a type of a code. But what is the difference between it and the topic or the node? So here is like it just publish every time it receive an image, it will publish it. Or like for example, every time a timer like say that we have passed 0.1 second or 1 second or anything we define, it will just publish whatever something is listening to it or no. It will just publish whatever, if anything like that triggers this callback. So for the service, it's a little bit different. So like we have a node and we have another node. So this node is just sending a request to the other node. And when the other node like receive this request, it do like a service and then send a response to it. So this is like the difference between them. So like it doesn't continuously sending a message. It's just like send and wait. So like this line doesn't have, or this bus doesn't have a message the whole time. It just have a message when something is triggering this service and go, and it will receive a response. So here is like some question of you might come. So some of you like may ask, so we have like a node that is publish a message. Like, look at this node. It's publishing a message. And another node is subscribe. So is only one node can subscribe? The answer is no. So like if you are publishing a message through a topic, so anyone can listen to this message. So anyone like subscribe and tell the name that I want to listen to this topic, it will listen to it. And this is like a very efficient way of communication, because like maybe you have like this node that is doing only a pre-processing, and you have like different modules that need like the cropped image, so you can pass the cropped image like to a different module like at the same time without a problem. So that's where ROS come handy, and it can save you like a lot of hassle for communication and this stuff. And also another question that can come to you, so like every node can publish or subscribe only? No, you can publish as many topics as you can. For one node, it can publish as many as topics as you can. It can subscribe as many topics as you can, and it can even have like a service or a client in it. So it's totally okay. You can design your system however you want. Like you can do anything with your system depending on your application. As you can see here, like this node, it have like a subscriber, and it have a service and client. This node, it have a service and a server, and it have like a publisher. And this node, it have a subscriber only. So like you can design the system however you want. So the TF, or transform package. So what is transform package? So in robotics or in like games development, you will always see like something like this. So like, for example, like we have like a robot base, and we have like the camera, and we have like anything like maybe LiDAR, mounting point, anything. So what are these? So this is axis, only axis, X, Y, Z. So what does it represent? So like in games development or in robotics, you need to know the location for each thing around you. So for example, like in games development, there is like the host, or the player you are playing with, and there is like other players or enemies around you. You need like to know the location of each thing, and each thing will be represented by this axis. So for example, like this is me, and the X is forward for me. Usually like X is the forward, and Y is on my left, and Z is up. And another enemy is coming towards me, so like the X will be forward to him. And these axes, we can like represent them, or it can be represented through matrices and a lot of transformation. So we call it like transform package. So like the transform package is a built-in package in ROS that can help us in doing this transformation without like doing much effort in it. So like it's help in doing like a lot of computations and a lot of stuff through ROS. So this is like kind of a small like insight about like the transform package. So like here is like a robot arm, as you can see. And for a robot arm, we need to define, like, for example, like this is we call the base link. The base link is something that is usually doesn't move, or the world link is something that usually doesn't move. But for any joint that is rotating or anything, so like if it's rotate like to a position, so like this axis is rotating with it. Why we are doing this? It's important. Uh, like imagine that we have like a lidar here. So this lidar is just giving you like the point cloud around it with respect to the lidar. So imagine that this lidar is rotated. So if this lidar is rotating, then you will see like the earth have its like rotating, like when you see on the visualizer. But if you are using like the TF and you know like the position or the rotation of each angle from the robot, then you will know how to compensate all of this and make like the lidar horizontal with respect to the wallet frame. So just bear with me, it's a very important concept for robotics and for games development. So for simulation, so for simulation, there is, I believe, like there is many simulations, but mainly what they are using is Gazebo. So what is like a simulation? Simulation is like you can use, as we said before, like you can use ROS with your hardware. You can communicate like ROS, like you can like connect the sensors data or get the sensors data to your system, and you can like do all of this like with ROS. And also another approach is that you can like away from your physical system, you can use a simulator. So the simulator is an environment, as you can see, that have like some robot, any kind of robot you define, and it can give you like, and it have like a sensors, and these sensors can give you like a data that kind of looks like the data from real life. So if we go to this link, so if we go to this link, we'll see like a lot of tutorials for this part. So like there is codes, URDF codes. So like I remember that URDF, it was Unified Robotics. Um, I don't remember the others, but it's just like a code that just define for you like what is this object, how it looks like, where its position. So for the simulator or for a gazebo, you can write a code to define everything. So I can write a code to define my environment. I can write a code to define my robot that is moving in this environment. I can even like use a 3D or a CAD or a 3D CAD. So like I can build like any model in my imagination and transform it into URDF with some tools. So and I can also use like maybe other people like have done this before or have used like to build some model, and I can use their models. So like I can build any environment, I can build any robot, I can put any robot in any environment I wish. So like it's really a very efficient tool which you can use. It gives you like a really huge flexibility if you don't have like a physical system and you want to develop. Also like there is a kind of other simulators like Unity. Also Unity, maybe some of you know Unity. Unity is using for game development, and also we even in my practical life, like as experienced in ROS and using ROS like my whole life, we also like have a team for simulator with which are using Unity to make like some robotic system, and we take like a message from this robotic system. So like we kind of like try to making it like looks like the real physical world as much as we can, and it help us in development, especially like in time when we can't use like our physical system outside, or for example our physical system have like some problem which needs to be fixed. So like we can use like the simulator in this kind of stuff. So like just like this is a quick look on how it's look like to write a code for Gazebo, and at the end it will look like whatever you are doing. And you can put like a plugin, for example, for camera, so it can like mimic the real, and it can give you like a data, a real like data that looks like the physical system. And you can like keep building like as much as you can. So like as you can see, here is the Gazebo, which act as your physical environment. And here is the Harvest. We'll talk about this later. It's just a visualizer, and we'll talk like later about like the difference between the simulators and the Harvest visualizer. So, and this was a very simple environment, as you can see, but you can build as complex environment as you want. Whatever you want to add, whatever you want to produce, whatever robotic system you are using, a drone or a car, a self-driving car, a small robot, a cleaning robot inside the house. So like you can build your own environment, and you can put like whatever sensors you want. Like you can use a plugins to put these sensors. There's a lot of like open source plugins that you can use to like use any kind of sensor. There is, so like for example, like you can use LiDAR and camera. You can use only camera. You can use LiDAR and camera and IMU and GPS. Like there is, I believe, like a really like big data, or a big like collection of sensors and plugins that you can use in the environment. So for the visualization, usually ROS is using Arvis as a visualizer, and we said that we will talk what is the difference between the Gazebo, which is a simulator, and the visualizer, which is Arvis. So the environment is acting as the physical world. So like we have a robot, we can see, and it have sensors. So, and it's trying to simulate the physical world. This is like the simulator. The Arvis is different. The Arvis is, or the visualizer is just giving you the data that the sensor is seeing. So like, for example, we have this point cloud. So it's just show you like what the point cloud can see. So for example, like we are here, our robot is here, and it can see like this, for example, like this house. So in the simulator, we can see like the real this house as we can see it in real environment. But what does the sensor see? So what does the sensor see is this. It just sees some points. So like the RV can show us what data is coming from the sensor. So it can be a point cloud that come from the LiDAR. It can be an image that come from the camera. It can be even like some axis that is rotate whenever we rotate. This is like the inertial I don't remember, inertial something unit, IMU. So like it's just the rotation. It can show you like the rotation. So it can show you like whatever data is coming from the sensor. And when you do like some processing, and you can draw a path here. So for example, like you have like a GPS data and you have an IMU data, and you can draw like the path that you have followed or anything. And as you can see, like you can have a node, for example, that takes a point cloud, and it passes through an AI model, and it give you like it parse like the output, which is the detections, the object detected as a bounding boxes, and it can give you like the bounding boxes later, and we can show it on Arvis as well. So also it can show you like where each object is located. This is like what we called like the TF, the transform package. The transform package is also have a plugin that can show it on RVS. So also like this is like what you can do with RVS. So for example, I can build like whatever objects I want. I can build cubes. I can build like a path, as you can see here. I can build whatever I want. Also, like you can have like some nodes that like after like you have like many modules and many nodes. So like you have your system have like its input data. It take like an input data from the lidar, input data from the camera, input data from the GPS, IMU, or anything. And many modules is doing like different stuff. So like maybe one module is just drawing the map, this outline map. Another module is trying to see what is the drivable area or and where we can go and where we can't go. So this is typically an occupancy grid. So what is an occupancy grid? Occupancy grid is like a map that we draw, a pixel map. It have like a value from 0 to 100. If it's 100, it's will be drawn as a black, and this means that your algorithm, your planning algorithm can't go through this obstacle. If it's white, this means that this is like a free place you can go through. If it's gray or this color, this means that doesn't know. It doesn't know like anything about like this cell. So for example, like our robot is here. For example, it fired a point cloud. It fired like some rays from the lidar. So it detected that there is an object here, but this rays can't pass this object. So like it doesn't know anything what is behind this object. So like it drew it as this gray cells. It doesn't know like if it can go here or not. But maybe like when it move like through this free cells, when it come here, maybe it will see here. So we can like update the map and we can like continue navigation about this. So let's sum up. So we talked about why we are using ROS, and we talked about like that we can use it with C++, with Python, and we can use Linux as operating system or with Windows. And we talk about like the structure or the executable, and when we add like the topic message in it, it can like act as like a node. We can call it a node because like it's used like some libraries from the ROS. And we saw what is the structure of our node, and we saw our service as well, and what is the difference between the service and the node. And the service is only like acting when it just request and receive a response, but not all the time. And actually this is save a lot like of headache or a lot of traffic on the system. And also like if some process that need a lot of time, maybe it's better to use a service. So like for example, you have an algorithm that take a time that take maybe 2 or 3 seconds, so it's better to use a service. So like it's receive a request and then we'll wait for it. Like it's better not to use it like the whole time. And we talked about like the simulation Gazebo, and we talked about like you can go to a complex system as far as you can. And lastly, maybe I can show you something. Just give me a moment. Oh, by the way, I want to mention that recently, so like we have like ROS1, and recently, like maybe some years ago, we like ROS2 was released. There is a difference between ROS1 and ROS2. ROS1 is actually I can't. So ROS1 have like some problems with the communication, with the underhood communication, which was fixed in ROS2. So like in ROS1, all the nodes should be like communicating with only like some like only one thing, which is called ROS master. So all the nodes is communicating with only this master. So if like a lot of nodes are communicating, so like the ROS master will have like a lot of like traffic on it. They fixed this in ROS 2. They are using like something called DDS, which like much more efficient. It's like every two nodes they are communicating together only. So if node doesn't communicate with another node, so it doesn't need to go through the master. And there is like some improvements in the messages and this stuff. I wanted to show you like something like how this is going in. Just give me a moment. I hope that I still have the video.
Reminding you, ladies and gentlemen, you are still with Mohamed Ahmed. He is talking about robotics. So please keep paying attention to what he's telling us.
So we can start with questions. So I have finished my presentation. We can start with questions, and meanwhile, I will search for a video and I will show you like some of what we are doing in real life.
All right. Thank you very much. That was Mohamed Ahmed talking to us, ladies and gentlemen, about ROS, ROS, Robotics Operating Systems. We're talking about a set of tools, libraries, conventions intended to ease up the overall functioning or operating of a robot, very basically. So it was indeed a set of kind of overwhelming types of data because this is science at the highest level, both science and technology at the highest level. And of course, this consists of a lot of technical jargon, technical terms, which sometimes can take, a special effort to truly comprehend and grasp. But this is exactly the reason why we are in the class. And like Mohamed Ahmed just concluded, he's now ready, ladies and gentlemen, for your questions. And we are beginning with Abdul Peters. Abdul Peters. Go ahead, Abdul. Your microphone is now unmuted. We are ready for your question.
Yes, good morning to you guys. Thank you very much for having me here. This program, this robotics subject is very interesting. It is very wonderful to have. Now we're in the fast-moving world, modern world of engineering as well. So it's a great topic here that the AIU would have had uh, doing here this morning. So I'm glad to be here and to produce my question. Thank you.
Thank you, Abdullah.
Great. Question here. How would the integrating system affect the ROS technology that we're having there, or you're having there actually? And are there any security features for these functions in totality of its functions with regards to handling and moving? So there are two questions there. How would the integrating system affect the ROS? And how are the security features for these functions in totality are established or met in terms of any
So
results?
Abdullah, let's take one question at a time, please. So what do you mean by integrating system?
Yeah, we said we're putting other functions to merge or to come together with ROS. So how do we have any effect of those? How or defects if it works efficiently, effectively?
Okay, so if you are talking about like libraries or you mean like maybe if I understand your question correctly, so like you mean by integrating systems that we are using different libraries, OpenCV, the ROS built-in packages, C++,
Yes, yes.
maybe, and all of this together. So like actually, it's really okay because like ROS is using like its own compiler, and this compiler can it's used like the compiler for the C++, the compiler for the CUDA, so it uses like everything for everything, and it's like a normal C++ code. So like whatever you are using with the C++ and whatever you can import with C++, it's applicable for us. So like it's not a problem. So like you can use OpenCV with Python or OpenCV with C++. You can use it with ROS without any problem. Just the only thing that you will need to do is that you will your CMake list maybe change it a little bit because like you will need like to add the built-in messages for the rows and this stuff, but everything will be the same.
Okay. Point taken.
Thank you very much for your response, Mohamed. We have a question coming on the chat line from Janet Radaby. Can a visualizer help identify potential drug targets within signaling pathways? I don't know if that's also very technical. Can a visualizer help identify potential drug targets within signaling pathways?
So if I understand the question correctly, it means that if we have like a drop message, for example, or some fault or a message that we didn't receive, so how we can detect this?
That seems to be the orientation of that question. Yes.
Okay, so yeah, for a message that is being transferred between two nodes or any kind of message, sure, we can have like a drop of message, a message that couldn't be received. So for example, if we are sending 1000 message, uh, maybe like 900 can be like received. So what to do about this? So the ROS2 is providing some software tools that's called uh, quality of a service, and this quality of a service you define whatever you want. So like I can define a reliable, I can define a best effort, I can define whatever I want. What does this mean? It means that I am telling my publisher or my publisher, for example, that's being published this message or so subscriber. If I saying like best effort, so like I'm saying to my nodes that do your best effort, try to send all the message, but if some message haven't been received, it's okay. For reliable, it's okay, try to be as fast as you can drop messages, but it's okay. But there is I remember like it was like some reliability or something else. I say like no, I don't want any message to be dropped. So even if you will get lag, just don't drop anything. So like ROS is providing this kind of feature.
Okay. Something else that is coming from Syed Umar Ahmed on the chat line as well. Let me see if I can mute that. All right.
So
This is a
what
question being asked by Syed Umar Ahmad. What is the relationship between ROS and artificial intelligence?
so it's the same relation between any programming language and artificial intelligence. So like any programming language or ROS is acting the same. It's just like we can say that it's a tool that you are using. You can write something doesn't totally relate to artificial intelligence, or you can like write like or you can like train your artificial intelligence model and you can like write it as a C++ later, or you can like have like your neural network in a file, and you make like your programming language reads this artificial intelligence model and use it. You have like an input and you have like the output from this artificial intelligence model. And so like it's kind of like abstract question. So like you can use ROS with artificial intelligence, or you can do not use it with artificial intelligence.
Quite clear. Ladies and gentlemen, I want to take this opportunity to not only thank you for your attendance, but also reminding you that we are with Mohamed Ahmed, an expert in the field of robotics. And today he has been talking about ROS, the very specific robotic operating system. If you have some other questions, he is still with us, although we just run out of time. But we, number one, Mohamed is available to answer additional questions that you may have, or you may also wait to get the full copy of the whole presentation in your student portal. If you are a member of an alumni, you may also get some type of email with the whole content at your disposal. Or you may also go back to our YouTube or Facebook pages to watch the entire recording of this session. I don't see too many hands around, but there is a question coming. Let's please just one question at a time. Let's go to Emmanuel Owe. This is your turn now, Emmanuel.
Okay, so I asked the question so the chat box. I think that one's about how fast can the node send a message or messages. Then I have another one. So the final
please,
element.
let's take one question at a time. Very, very important, because I'm
Okay.
so sorry. We have run out of time already. And we have another hand up after Mohamed answers your question. We're going to have to conclude with Collins Emerson. Go ahead, Mohamed.
So this is a very good question. So usually like it can go as fast as you want. It can go like, for example, like on like IMU can send 400 message or 500 message in a second. So like the system can send like 500 message in a second. It's not a problem, and it can even like send more. It depends on the physical system itself. So like for the LiDAR, it can send only 10 messages per second. For the camera, it can work with 30 frame per second, for example, or 60 frame per second. So it depends on the physical system. It can send as much as messages as you want per second. However, you need to take care about like the resolution of your camera. So like for example, if your camera is working with 60 frame per second and each image it's sending like it have a very high resolution and it's sending an 8 mega, then this can be an overhead for your bus, and maybe you need like a fast network, or because like this is one of the problems that we dealt before. But however, like the ROS can provide any speed you want. Just like you need to take care that your like hardware supports this speed.
Okay, thank you.
Welcome. I can't hear you, Dr. Professor.
I am so sorry.
No problem.
I was so engaged in that session about robotics that I became a robot. The last question I was about to announce with now Collins Emerson. Collins, your microphone is now unmuted. The floor is yours for your question, please. Let's see if we can get Emerson.
So until Collins answers, so like this is a video. It's a kitty that set. I was testing on it like some approaches. So like Here, as you can see, like the image that is coming from the camera. Here is the point cloud, and this green path that can be, this green path is the path that I'm following, and this bounding boxes is the detection. And if a car is moving, it will have like many bounding box in front. It's just the prediction for the movement of this object. If it is still doesn't move, it will have like only a bounding box in its position, as you can see. So like this is also like we can say it's kind of application for that I'm using ROS for. All of this message I couldn't be visualizing at the same time without like the ROS.
All right. With this note, ladies and gentlemen, we are putting an end to our session today, our live class with Atlantic International University. We could not get to Collins Emerson, whose microphone could never come on, unfortunately. But I want again to thank each and every one of you, ladies and gentlemen, for your participation, for your attendance. Reminding you, like a question being raised right now by Levine Stubbs, yes, a certificate will be provided to those who have attended the sessions. As a matter of fact, you will get 0.5 credit, academic credit, which you may apply to your program at AIU. Or if you are an alumni, then you will receive indeed a certificate. Thank you, each one of you. Now going back to you, Mohamed, if you don't mind, for a quick conclusion, please.
So a quick conclusion, as we said, that ROS is an operating system that is working on the top of operating system. ROS can help us one time or another. If you are working with robotics, you will need to use ROS. Why? Because it have a very sophisticated infrastructure for passing messages. It have like a visualizer. You can use it with a simulator. There is a huge community for it, and there is like already a lot of stuff that have been developed that you can use. You don't need like to start everything from scratch. You can like work where like the others have stopped. So like that's like in a summary or a conclusion, Ross. If you will work with any robotic system, so probably you will work with ROS. And there is a lot of tutorials on the internet to get more deep into ROS. Even like the ROS itself, the ROS company itself, like it's providing a tutorial, step-by-step tutorial you can follow. Provide like step-by-step like how to install ROS, how to use it, and even examples that you can use. So if you are interested more in this area, you can go and dive more into this. So what we have been said today is just, in a matter of fact, it's just like a drop from a drop from like a sea. So thank you all for attendance, and see you next time.
It was very, very awesome. And at this time, ladies and gentlemen, I'm asking you to your microphones are on to together say thank you to Mohamed Ahmed for
Mr. Mohamed. Thank you very much.
Thank you so much for coming.
Thank you very much.
Thank you. Good job.
Thank you, Mohamed.
Thank you.
Thank you, Mohamed.
Good job.
Thank you.
Have a good evening for your presentation.
Thank you.